Our project aims at visualizing how food production will change with respect to the climate change. Our visualization starts off with the journey map. The user can either click to skip it or click to start the journey. So, assume we start the journey right now. The text starts off with a brief description. I will briefly read it to you. What if tomorrow we've discovered that due to climate change that the price of production of rice/potatoes will quadruple? Or even worse, we discover that these ingredients will not be able to be produced anymore. We know that these key ingredients are quite predominant in today's culture. Furthermore, we find out that our grocery expenses will increase exponentially. It is estimated that there will definitely be an increase in the population size in the future. Logically, the increase of the latter should lead to the increase of production of food. But taking into account climate change in the equation increase doesn't necessarily lead to food production increase. With this visualization, you will be able to explore different aspects of food production with respect to climate change. In this phase, there are 3 types of maps you will be able to explore. The first one is the world map, the second is a cartogram, and the third will be a detailed version of a map. Let's explore the map. As you can see, this is the world map, the first map. So given our data set, we have different choices of maps. We can either choose a scenario. There are 5 scenarios here. There are 5 models here, CC, GS, HC, and M. And the type of map we wish to display, either calorie map, precipitation map, or altitude. Since our dataset only has 1 year, we have 2005, 50, but in the future we might maybe extend it to have more years. So let's see. For example, if I choose SSP1, model CC, type of map calorie, and year 2050, we will see a coloring of a map. This map shows the aggregated values of, for example, the type of map calorie. As you can see, if you hover around the map, you can see United States has 4.5 billion calories in year 2050. Canada has 11 billion. And also Africa, you can see that the calories in Africa are quite small. You can navigate around the map. You can zoom in. So if I want to have some information about a certain country, let's say Switzerland, since we're Swiss. So we choose Switzerland. Just be patient, it loads sometimes, since in our dataset we have 20 million points, so we have to process them. So as you can see, this map displays, this sidebar displays the region of Switzerland. You can hover around the bar chart to see the certain information of each region. For example, for calories for CC model with all SSPs, and the calories for the chosen scenario SSP1 for all models. So this just shows you the production of calories of Switzerland in each region. Right now, if I want to compare with other countries, with other regions, I have to click on the bar chart here. So as you can see, for example, here, if we click on Zurich, we can see that how the production of calories differs with certain regions. So as you can see, a red value means that the region will have produces less calories, and green means it produces more calories. This can also be done with also SSPs and models. So if you want more information about a country, some countries don't have information. For example, Switzerland, we weren't able to scrape some information about Switzerland. But for example, if we go to France, and we get some extra information from France, we can see that France is the second largest country in Europe. Much of this country is surrounded by mountains, and just gives you more information about the food related topics in France. Now, a second part of the map is, for example, right now we have the aggregated values. So if we wanted to see the aggregated values per region, we'd click on France, then we'll click on the aggregated map, which is our second type of map in the world map. So in the same way, we can navigate and see the detailed version of France. We can go back, normal map. For example, if we choose Portugal, we choose the aggregated map of Portugal. We can also choose a precipitation map. Here, right now I choose 2050, model GS SSP2, and this will give the same effect. So if I wanted to narrow down on a region, for example Brazil, we can see the precipitation in Brazil. Or if we can choose altitude, we go back, and since we like Switzerland, we will choose the altitude in Switzerland. We can also see the aggregated map of the regions where it's really high. Now we displayed the cartogram. Let's go. So the cartogram was given by it was an idea given by the teacher, so we tried to implement it. We tried to see the libraries that implemented it. Even though it's not perfect, but it still tries to show which country, for example, if a country has more calories, the country should be bigger. In our third type of map, there's a detailed map where we actually display every single pixel in the dataset. So this was a choice because since we had over 2 million points, we decided to display only the amount of points per country. So if we go back to the world map, here, for example, we generate the detailed version of a country. For example, if we choose Switzerland once again, and we go to the detailed version of Switzerland, you can see these are all the points that are projected. And here, on this final page, we have a slider in which you can compare different aspects of what changes between two scenarios. For example, if I choose GS here, we will see how it varies. As you can see here, there are some points that are vanishing and some that aren't vanishing. If I vary altitude, some points vanish from one map to the other. If I vary the workability index, you can see if we go to the maximum value, we have no points left. Well, I guess that's it.